So, in this class, I will discuss that what would be the earth pressure if the soil is C5 soil. Okay. So, last all the earth pressure problems I have discussed that soil is only phi soil. Now, today I will discuss if the soil is the C5 soil. Okay. So, now so in general that when we design a retaining wall or earth retaining structure, we design it against the active condition. Okay. Now, the question is why we will not design it against the at rest condition. Okay. So, that means the active condition, the one reason is that if I design it under active condition, then our earth pressure will be less compared to the at rest condition. So, our force that will come onto the on the wall will also be less. And one thing that if we want to design it for the active condition, then we have to allow a certain amount of deformation of the wall, and that is acceptable because we can allow a certain amount of deformation, because all the foundation design also we will allow certain amount of deformation, or that is called permissible settlement. So, you design our foundation under permissible settlement. So, here also we can design our foundation or retaining structure under active condition, because in generally in the practice retaining wall is generally constructed, then the backfill soil is placed. Okay. So, during this process of backfilling, the certain amount of wall deformation away from backfill will have taken place. So, since the deformation is very less to form a active condition, so a retaining wall is always designed under active condition. Okay. So, you can see that for this active amount of translation at top. So, amount of translation at top means, suppose this if your wall, so that means on the active condition it will deform like this. Okay. This is the original and this is the deform. Okay. So, this is the amount of deformation of the top or translation of the top, and that is say delta x. So, for the cohesionless soil dense, this is if this is the height of the wall, then this delta x is 0.001 h. That means, it is only 0.1% of h or 2.2% of h. So, if we have that much of deformation, then the active stage will occur. So, that is why that much of deformation we can allow, and we can design it under active conditions. So, for the cohesionless soil, so loose, this is 0.2% to 0.4%, and cohesive soil, if it is steep, it is 1% to 2% or 0.1 to 0.01 to 0.02 h, and for cohesive soil soft, it is 2% to 5%. So, it is very small amount of deformation to get a active stage. Okay. So, now, we will discuss that what will happen Rankine if the what will happen to the Rankine's active earth pressure if the soil is cohesive soil or it is a C5 soil. So, here the soil is C5 soil. Okay. So, in that case this will be the Morse circle, because in the cohesive soil your Morse circle there will be a C value and there will be a phi value. Okay. So, I can prove that how I am getting this expression. This is the final expression. So, let me prove that thing first, then we will discuss the forces and the point of applications, all those things. So, now if it is a C5 soil, then I can write or I can draw this Morse circle, but here it will not pass to the origin, because it has a C value as well as the phi value. So, this is the phi value and this one is the C value cohesion. Okay. And this is the your Morse circle, and this is again this is sigma 1, this is sigma 3, this is the center. So, center will be sigma 1 plus sigma 3 divided by 2 plus there is a term. This is C, this is phi. So, these things I can write, this is C cot phi, okay? Because this one is the C equation, this is the phi. So, I can write this amount is C cot phi. And so, if this is the origin O and this is tau and this is sigma and this is the center C, and I can draw a line, this is the P where this circle touches the failure envelope, and this point is say R. Okay. And similarly, the radius, this radius will be this radius sigma 1 minus sigma 3 divided by 2. Okay. This is the radius of the circle. Now, I can write that sin phi is equal to, again sin phi will be P c divided by R c or C r. Okay. Again the P c is here sigma 1 minus sigma 3 divided by 2 and R c is C cot phi plus sigma 1 plus sigma 3 divided by 2. Okay. So, now I can write here that C sin phi cot phi plus sigma 1 plus sigma 3 divided by 2 sin phi will be equal to sigma 1 minus sigma 3 divided by 2. Okay. So, now cot phi means the cos phi divided by sin phi. So, sin phi will cancel out. So, I can write C cos phi plus sigma 1 plus sigma 3 divided by 2 sin phi, that will be equal to sigma 1 minus sigma 3 divided by 2. So, I can further write that 2 C cos phi plus sigma 1 plus sigma 3 sin phi will be equal to sigma 1 minus sigma 3. Now, if I take all the sigma 3, sigma 1 this side. So, sigma 1, if I take common, this will be sin phi and this will come this side. So, sin phi minus 1, and if I take sigma 3 all in this side. So, all in this side. So, this will be sigma 3 minus sin phi, this is also sigma minus. So, plus 1, okay. And again the minus 2 c cos phi part. Now, if I take minus common and cancel from both the sides. So, this will be sigma 1 minus sin phi, that will be sigma 3 1 plus sin phi, that will be plus 2 c cos phi. So, I can write sigma 1 is equal to sigma 3 1 plus sin phi 1 minus sin phi, and this will be plus 2 c cos phi 1 minus sin phi. Okay. And this cos phi I can write that cos phi is equal to root over 1 minus sin square phi. So, in the sin square phi I can write this will be 1 minus sin phi and 1 plus sin phi. Okay. And this 1 minus sin phi also I can write, this is root over 1 minus sin phi square. Okay. So, this one I can write in 1 minus sin phi is nothing but this is root over 1 minus sin phi square. So, now if I put these things, so that means here 1 minus sin phi and 1 minus sin phi 1 will cancel out, and there will be root over 1 plus sin phi divided by 1 minus sin phi. So, this way I can write this is sigma 3 1 plus sin phi 1 minus sin phi plus 2 c, then root over 1 plus sin phi 1 minus sin phi. Okay? Because here 1 minus sin phi, 1 minus sin phi, that 1 will cancel out. There will be root over 1 plus sin phi, and this is 1 minus sin phi. Both are within the root. Okay. So, final expression is this one, or I can write that sigma 3 is equal to sigma 1 1 minus sin phi 1 plus sin phi minus 2 c root over 1 minus sin phi 1 plus sin phi. Okay. So, we have two expressions. This is sigma 1. So, we have expression number 1 or expression number 2. So, expression number 1 is sigma 1 is equal to sigma 3 with some value plus 2 c, and the same expression I have written in different form. Here sigma 3 is equal to sigma 1 into that expression into that 1 minus sin phi divided by 1 plus sin phi minus 2 c. If you take this thing this side, so it will be minus 2 c. Now, for active case, that your sigma 3 is equal to P A and sigma 1 is equal to gamma z. Okay? Because this expression I am deriving is not for inclined surface, it is for perfectly horizontal surface, I value is equal to 0. So, I can write this expression. So, I can write for active case our P A is equal to gamma z 1 minus sin phi 1 plus sin phi minus 2 c root over 1 minus sin phi 1 plus sin phi. Okay. Now, 1 minus sin phi 1 plus sin phi is nothing but K A. Okay. So, I can write this is gamma z K A minus 2 c root over K A, where K A is equal to 1 minus sin phi 1 plus sin phi. Okay. So, this is for the active case. Okay. Now, for the passive case, so I have this expression sigma 1 equal to sigma 3 1 plus sin phi. So, I have expression sigma 1 is equal to sigma 3 1 plus sin phi 1 minus sin phi plus 2 c root over 1 plus sin phi 1 minus sin phi. Okay. And for the passive case, your sigma 1 is equal to P A, okay, and sigma 3 is equal to gamma z. Okay. So, I can write sorry, this is P P. So, I can write that P P is equal to gamma z 1 plus sin phi 1 minus sin phi plus 2 c root over 1 plus sin phi 1 minus sin phi. Okay. And again gamma z into K P plus 2 c root over K P, where K P is equal to 1 plus sin phi 1 minus sin phi. Okay. So, this is the expression of A and K P for C phi soil, and this is the expression of P A and P P for the C phi soil. Now, so this is the same expression that sigma 1 equal to sigma 3 1 plus sin phi. So, that and the sigma 3 expression I have already derived. So, from here I can write P A is equal to gamma z K A minus 2 C root over K A, and this is the Mohr circle, and again the Mohr this failure plane will make an angle 45 degree plus phi by 2 for the active case. Okay. And similarly for the passive case, similarly for the passive case, this is the same expression K P, this will be plus 2 C root K P. So, I have derived these expressions. So, K P is 1 plus sin phi, 1 minus sin phi. This is for the passive case. But and we have few more cases. Okay. So, this is the Mohr circle for a general case. Okay. Now, we have this is the expression of P A. Okay. This is the expression of P A, and this C A is the circle corresponding to this expression. This is the circle corresponding to this expression. Now, if P A is equal to 0, this P A is equal to 0, then we can get a Z value. If P A is equal to 0, then from here Z value will be 2 C K A by gamma K A, and this is K A. So, I can write 2 C gamma root K A. Okay. So, this is the value 2 C gamma root K A. So, here your P A value is 0, and you know that P A is nothing but sigma 3. So, your sigma 3 value will also 0. So, remember that in that case your Mohr circle will pass through the origin, because your sigma 3 is value is equal to 0, because your P A is equal to sigma 3 and P A value is 0. So, that means this is the this circle. Okay. So, now if I put at z equal to 0, at z equal to 0 means this is your sigma gamma z into k, that part is 0. Okay. So, you know that your sigma 3 is equal to P A and sigma 1 is equal to gamma z. This is for active case. So, now if gamma z is or z is 0, that means sigma 1 will be 0. So, in that case also your Mohr circle will pass through the origin, but in that case your sigma 3, that means sigma 3 value is minus 2 C root K A, because if you put this is 0, this is 0, this will be the minus 2 C root K A. So, your Mohr circle will shift to this origin, this side of the origin. Okay. So, now this is the case for this Mohr circle. So, this is very important, these 3 circles. So, it is a very common questions that if your P A is 0, what would be the Mohr circle? If your Z is equal to 0, what would be the Mohr circle? Okay, then you have to draw Mohr circle in this way, and remember that in that case sigma 3 will be 2 C root K A, and here the sigma 3 is equal to P A for the blue, and here sigma for the second circle sigma 3 is equal to 0 and sigma 1 is equal to gamma into Z 0. Okay. So, you just remember these things. Then another important thing that I have already mentioned, that if your P A is equal to 0, then your Z 0 is equal to C gamma root K A. Okay. So, does it mean that at Z 0 point your stress is 0, lateral earth pressure, active lateral earth pressure at Z 0 is equal to 0. So, and above this Z 0 your earth pressure is negative, because we have minus C term. Okay. So, this is negative. Actual expression is your P A is equal to, you can see this expression that P A is equal to this is the expression P is equal to gamma z into K A minus 2 C root K A. So, I can write that P A is equal to gamma z K A minus 2 C root K A, you can write small a or capital A. So, that means here if your up to the z 0, this is negative part is more compared to the positive part. After that it will positive part will increase. So, up to this point there will be a negative earth pressure. That means here a tension will. So, this is the negative means it is a tension. So, this is the tension zone. Okay. So, here your tension crack will develop, because soil cannot take tension, soil is weak in tension. So, and your stress is negative. So, here that means there will be a tension crack will develop in this zone. Okay. There will be a crack will develop in this zone up to z 0. Okay. And another very important thing, that now this way the stress is acting in this direction, because in the it is negative, and this side your stress is acting in this direction. Okay. Now, there will be an equal amount of z 0. So, this stress will cancel this stress. So, this positive stress will cancel this amount of the negative stress, because if I draw this triangle is same as this triangle. So, if I do not provide any support up to the twice z 0 from the top of this ground level, then there will be no issue. Because there is no stress, this stress is equal to this stress. So, no support is required up to twice z 0 depth from the top. After that you have to provide support, because again this stress will be the additional stress. So, that twice z 0 is called the critical depth of a vertical cut. So, up to the critical depth you do not need to provide any lateral support. Okay. So, if you remove the soil up to twice z 0 or h c, the soil will stand without any support, because the positive stress is cancelled by the negative stress. Clear? But if you excavate further HC, then the support will be required. So, that depends upon the amount of shear strength parameter C or phi of the soil and the unit weight of the soil. So, this is the very important concept. This critical depth concept is very useful and very important. And now, there is two cases. One case you will find that you have to draw the earth pressure. This is very common question, that you draw the earth pressure before the tension crack appears and the after tension crack occurred. So, what will be the earth pressure, what will be the force before tension crack occurred and after tension crack occurred. So, before tension crack occurred means you have to consider this negative pressure also. So, if you consider the negative earth pressure part, then how we can determine that? So, if I consider this negative part also, then I can write this expression. So, this is the rectangle I am taking, and here this part this total soil is nothing but this is your H, and this is this total one is nothing but gamma into H into K A. Okay. And this one 2 C minus K A. So, now if I consider this portion also, then I have to write this gamma, this triangle half gamma I square into K A, this triangle half gamma. So, this means this triangle is half gamma h into K A into h. This is this triangle minus this rectangle. This rectangle is 2 c root K A into h. So, if I take the rectangle, so this portion will cancel out, and this is the we are taking once this one within this triangle, we are taking this portion with the rectangle also. So, both will cancel out. So, only this one minus this one. So, this is the, so that means here this will be cancel out if this is the earth pressure before the tension crack is occurred. Okay. So, this is the earth pressure half gamma square K A minus 2 c h into K A. So, that means before the tension crack is occurred, you have to consider the positive as well as the negative earth pressure during the total force calculation. Remember that if tension crack is not occurred, then we have to consider positive as well as negative earth pressure during the calculation of P A. Now, if the tension crack is occurred, then there is a separation of the soil and the wall. So, we will not consider the negative one, we will consider only the positive one. Okay. So, if we consider the only the positive one, then this will be your portion of the stress. That means, what is the portion of the stress? This one, this value is nothing but this is gamma into h into K A minus 2 c root K A. This is this portion, and this value is h minus z 0. Okay. So, this triangle is half h minus z 0 into this one gamma h k minus 2 c root k. So, if you simplify this thing, this will be the form. Okay. So, these things that after tension crack is occurred. Okay. So, these are the two different cases, but during the design or calculation of active earth pressure, we generally do not consider this negative part. Okay. So, if it is mentioned specifically that before the tension crack is occurred, you calculate the force, then only you consider this negative one. Otherwise, if nothing is mentioned, then we generally do not consider this negative part. We consider only the positive part during the calculation of the earth pressure. Okay. Remember that. So, that is why we will generally this tension zone usually ignored. Okay. But if it is specifically mentioned that you calculate the earth pressure before the tension crack is developed, then only you have to consider, otherwise do not consider. Generally it is been ignored, we consider only the positive one. Okay. And then next one is that if there is a water table in this C5 soil also, if there is a water table, then what would be the earth pressure distribution. So, I have already discussed in case of phi soil, it is also similar that if you have a water table up to this H1, then H2 is the below water table. So, that means, if this Z0 is within this H1, then this will be the distribution up to this point, okay? And then this one will act as a surcharge here, then this portion is for the additional stress of the lower part, then this one is the water table part. So, this is the three different parts similar to the your phi soil also, but only there will be a negative zone. So, this is the negative zone, and why the generally as I mentioned during the force calculation, we consider this shaded portion only, which is the positive part only. So, that means the final calculation is we are considering that this is the half into H1 minus Z0, this is H1 minus Z0. So, this is half into this value is gamma into H 1 into K A minus 2 C root K A. This is this value. Okay. So, that is and here the gamma will be gamma T or gamma bulk or gamma dry. Okay. Gamma bulk or gamma dry. So, that means here it is written gamma T. So, you can write gamma D H 1 K minus 2 C in root over K A. Then next part we have to consider this portion, this value is again nothing but the same value, this one and this one the same. So, this is the gamma D. So, this will be the rectangle and that is the rectangle. So, this is the rectangle we are talking about. So, this is this value into H 2. So, this is the H 2. So, we are talking this value into H 2 plus this triangle. This triangle is this is the gamma sat minus gamma W, this is gamma bulk. So, gamma bulk into H 2 into K A and plus gamma W H 2. Okay. So, that means here you add these two and then this will give you this. This is the force for this triangle, okay, half into gamma B H 2 square into K, and for the water one, this is the third triangle whose height is H. So, this how it is coming, this is the half into H into gamma W into H 2. Okay. So, this will give you half into H 2 square gamma W. Okay. So, this is the first part. So, first part is this one, this is the second part is this one is the third part is this one, this is the fourth part, this is the fourth part. Okay. So, this is the 4 parts, you divide it into 4 parts and you can calculate. This portion is due to the water and this portion is due to the soil. Okay. So, this way we can calculate the forces if the water table is also existing in the C5 soil. So, this is the passive earth pressure case I have already discussed, but the earth pressure distribution here there will be no negative pressure will develop, because here the value is this is gamma H K P plus C. Okay. So, this is plus C. So, no negative pressure will develop. So, first gamma into H into K P, this is the rectangle, this is the rectangle for the 2 C root K P. So, this is the rectangle for 2 C root K P and then this is the triangle for gamma H K P. So, this is the earth pressure distribution. So, now we have 2 cases, this is first and this is second. So, your first case, this is for the first case and this is for the second case or second distribution of the earth pressure. So, first case this is 2 C root K P into H, this is the rectangle and this is half into gamma into H square into K P for the triangle. Okay, because for the triangle this will be the half into H into gamma H K P. This will be half gamma K P H square. Okay. So, this way we can determine the forces, but remember that here it will act at the height of H by 3 from the base, here for the this rectangle it will act the height of H by 2 from the base. Okay. So, this way we can determine the forces of passive case also. So, in the next class I will solve few examples to show you how we can calculate the active earth pressure and the passive earth pressure if it is a homogeneous soil, dry condition and submerged condition, with or without surcharge, and if it is a layered soil also, layered C5 soil or layered C5 soil. Okay, and then we will calculate the forces and point of application of that forces also. Thank you.